Thank you so much for the introduction. So, as he said, we're going to be looking at how to build full-stack apps with Go. And this is the idea of this talk is to compare the traditional approach of building web apps, dividing into backend and frontend, and this new approach of using server-side rendering to build our apps. And mind you, I use the quotation marks there strategically because when we talk about the web, this is a bit of an introduction on the web. We have to talk about, well, Tim Berners-Lee in 1989, he built what we know as the World Wide Web, which was the browser, the HTML, the hypertext markup language, and the hypertext transfer protocol over the course of 2 years, so almost nothing. And this basically started what we know as Web 1.0. At this stage, websites were nothing more than brochures, so they just displayed information. There was no personalization, so every user would see the same thing. And at this point, in my opinion, it makes sense that if you are showing HTML, static HTML, as a developer, the next step that you're going to take is to dynamically render that HTML. So essentially, you are server-side rendering that content so it adapts to every user that visits the website. So that's why I said server-side rendering being a new thing in the community. It's been around since the 90s. At first, you would have CGI scripts, which would render the HTML. Then, well, you would use Perl for those or any other languages. You could use it with Go. Then we had specialized languages like Microsoft Active Server Pages, PHPs, JSPs, a lot of Ps. And at the same time, as the backend was being developed, you also had development in the front side. Well, there you go. Ooh, no, not so fast. OK, so we had CSS and JavaScript pop up. So CSS would give a style to the HTML, which was plain HTML is not that nice. It's very boring. And JavaScript added that layer of interactivity. And then people were starting to have fun. And you would have really cool websites from the 90s. And yeah, they were having so much fun. And they were figuring out, oh, how can we make things more dynamic, more interactive? And it started to make sense to specialize into front-end and back-end. You have a specialized front-end. Well, this is the traditional approach where you would have your browser, make a request to the server, get back the HTML, and render it. Then it started to make sense, and mind, this is a very high-level diagram, don't take it too seriously, but here we have your browser interact with the client on the server side, and that's the one making the requests to the server, which is the backend, and gives back a JSON file, which then the client will generate into HTML and render it to the browser. So the website that we're going to be building in this session is a very simple website. And the idea is to go through, this is an e-commerce, a very basic e-commerce, and we're going to be building as an SPA, and then we're going to see how to make it server-side rendered. The whole idea is quite simple. We have a list of products. We have all these wonderful items that I've generated, the images, and they did not look too good, but it's what it is. And then when the user clicks on a product, they will take it into a website where they can see more information about the item. So you can see here, this is a Gopher plush. I generated this with Midjourney. This is the idea that they have a Gopher plush. It's not that nice, but it's what we have. And then when the user clicks the Add to Bag button, of course, we're going to be updating that card in the right corner, the top right corner. And this is going to be persisted to the server, because this is like in modern e-commerce, you want to have your card persisted across different sessions, across different devices, just like Amazon does, for example. We click the button, we get updated. So that is that level of interactivity. So when we start working on this app, the first step would make sense is to break it into components, right? This is the approach that React takes. But we're going to be using React for the SPA. So the components would be, so we have the app, and then a header at the top, and then we have our content here, which is the product list and the product overview. As you can see, nothing changes that much between the two sites. The only thing that changes is going to be the product list or the product overview. And then we're going to have each component be calling a different endpoint. So in the case of the product list, it will call the products endpoint to get the list of the products, which is 100 products. And then in the case of the product overview, is going to get the detail for that particular product. And we're going to have our cart in the corner, which is going to be using the cart endpoint, which is both a get and a post endpoint. So in the case of the get, we'll get the cart count. And in the case of the post, we send a new product. And the server will update the data there. So if you build this with the server side, the backend, when you build it as a Go service, you would probably, hopefully, be breaking it down into layers. I copied this layer structure from the workshop, the Ultimate Go workshop by Bill on Wednesday, and I think it makes a lot of sense, but you probably have a similar thing going on in your projects, where you have, in this case, you have the storage layer, which is going to be using the database, the business layer, which is going to be the business logic. We're not really going to care about this because they are not going to be changing from an API that returns a JSON to an API that returns a server-side rendered website. And then the app layer, which takes care of the encoding. In this case, we're going to be doing JSON or HTML. And the API, which takes care of the transport, which is, in this case, HTTP. And the data will flow down the stack. The idea is that you get the JSON at the HTTP level, you serialize it into a struct, you pass it down, and then the data flows upwards. As you deserialize at the top level, you would deserialize the data into JSON. So going back, we're going to take a look at this is the product list. So how would we go to build this in Go? Like I didn't say, but the framework that we will be using is Templ, which is a framework that allows you to template things in HTML and render them in Go. And this is basically the code. I don't know if it's too visible, but what I did is I first wrote this in React, and then JSX, and then I copied it over and just modified what was needed, which is just this for loop right here, which is the one that is rendering the product. It's not, and then of course you can embed the Go into the specific HTML, so it makes it very easy to take an app that's built with JavaScript and translate it to a server-side rendered one. At the top there, we get the products as the parameters that we are going to be rendering. Then when we use this, we're going to be embedding this product list, and along with the header, which takes the cart count, we're going to be embedding it into the homepage. And of course, the homepage, to render those components, it needs the product list and the cart count. And then you see there is some HTML there for the CSS. I'm using Tailwind, so I'm using an output CSS there, right? Very simple. And when we want to run this, we just use these three commands. So you have Templ generate watch. It will take care of updating your Templ, watching your Templ files, and when you make a change, it will generate the Go file that goes along with it. You can see that in the right. This is a Visual Code extension that allows you to see it. It's very simple, it's very easy. The tooling around Templ is amazing. You also have some options from the standard library and other templating frameworks, but I think Templ is great. And then this command right here for Tailwind, we're using the standalone binary to watch our input. Well, basically, it's watching the Templ files. We can configure that in the Tailwind configuration, so that when we add a class to one of the class that you can see here, when we add a class, we change the classes, it generates the CSS that goes with it. So very, very simple. And now, okay, we have made the templates, right? But now we have to serve those. So what we have to do is we declare our handler, which is going to take care of, in this case, it will read a cookie from the request, which will be used to identify a user and to get the card. That's the only level of personalization that we're doing at the user level. And with that card, we're then, with that cookie, we'll then get the product list and the cart count, and then pass those along to the homepage, which is the one that's going to be rendering all that information. So what we've essentially done is nothing more than adding a different type of encoding to our API. We build the API in JSON, and if we want to server-side render, we just need to change the encoding. So ideally, if your app is divided into packages and you have divisions and you are using interfaces the right way, in my opinion, you should be able to to add this type of encoding with HTML, not having to change a lot of things in your code. And then the transport is going to be the same. It's going to be HTTP. There's nothing changing at that level. OK, so that's it for the introduction. This is what we're talking. This is what we're going to be working with, the SPA single-page application, which is using React. And then we have our backend that is serving a JSON. And we have our other server, which is server-side rendering the components and serving them through HTML. So what about some numbers? Here we're looking at the average payload size when we hit the endpoint. In the case of JSON, and here when I talk about HTML, I'm talking about the home page. So in the case of JSON, it's 54 kilobytes. In the case of HTML, it's 43. This is quite surprising when I saw this, because I was expecting it to be more heavier for the HTML. That was my assumption. And it was wrong, because even though HTML is a more verbose encoding, the key thing here is that when I was building my API, I'm sending over all the products, all the information for every product in the product list. So that means that we have 100 products, and even for this page, which is the home page in the SPA, we get information that ends up not being in the HTML. It's not really rendered, because in this case, for example, we have the ratings, we have the description, which is not actually going to be rendered. But when we are doing it on the server side, we're rendering the components, we decide what data we're going to encode, and we only send what we need. So going back here, and that's basically the main thing, where the home page HTML ends up being smaller. But when we look at the average handling duration, HTML ends up being much slower. So this is where I started to, oh my goodness, this cannot be. Because now I come here, I try to sell you the idea of that you should server-side render your components, oh yeah, full stack, all that good stuff. And I end up showing something that ends up being basically 17 times slower than JSON. So it's not a good show. It's not a good show. But then I decided to put these numbers into perspective. And that's when we look at the average latency. So, of course, we're talking about before is the average handling latency. That's the time it takes for the server to generate the response from the requests. But there's something very critical that needs to happen right after that, which is the actual content needs to make its way to the user. And here, I was connecting using, I was hosting my server in US East 1 using AWS. So I ended up having a latency of 82 milliseconds, which is reasonable. That's the time it takes to go there. The time to connect is the ping. You can think of it as the ping. And then the time of the first byte, so that is going to be, in the case of JSON, 165 milliseconds. So the math checks out. That is 82 milliseconds to get there, to get to the server. Then, as we saw before, it takes about 0.3 milliseconds for the JSON to be ready, and then 82 milliseconds to get back. So that is 164 plus 0.3 and some rounding errors. The math checks out. And in the case of HTML, now that is 172. So 82 plus 82, 164, and then some time to generate the HTML, which is a bit slower. It's going to be 5 milliseconds, around that. But at the end of the day, the total latency of all this operation was only 331 milliseconds for the JSON and 337 milliseconds for the HTML. And now this was only 1.8% slower. So this is a much more promising thing. I mean, it's a lot better than 17 times slower. The only thing at this point was that, well, it's still slower. Full stack is still slower than an SPA. But here we are I decided we're not comparing actual apples and apples, we're comparing apples and oranges. Because so before, this very simple diagram of how the browser sends the request to the server and then renders the HTML, whereas in an SPA, we have a client or a front end, which is the one sending the request to the server and getting back the JSON. But let's break this down a little bit, because now we have our user, okay, and they go to their favorite browser, which is Internet Explorer, of course, and they make a request to an unknown thing, we'll talk about it later, that gives it the HTML and JavaScript and the CSS that it needs to get the SPA started. Once the SPA is started and the JavaScript is ready to go, it then makes a request to our server, which is the JSON server, and it gets back the JSON, which is then rendered, and our user is happy because now that's when they get the actual web working. But the problem is, this unknown thing is extremely fast. It's as fast as you can get in the web. But even then, we're talking about 6 milliseconds to go there. And in total, my test, 20 to 30 milliseconds to get the files back. So compare that to our server-side rendered. We have a user. They go to their favorite browser. We go to the server, and it comes back. We don't have that step of fetching the SPA because we're already getting working HTML. In the previous case, then, it ends up being slower, and then you might say, okay, yeah, but this step of getting the HTML and CSS only happens once the website loads, and then for subsequent requests, you don't really need to be getting that because the JavaScript is already loaded, and you might have a fair argument there. However, now is when I want to talk about this, well, let's go forward, this magical component, because some of you might have guessed it. What we're talking here is about a CDN. In this case, I was using AWS CloudFront. And it's basically the whole idea of a CDN is that your you might know it from when you have to serve images and videos and things that are static. That's where it specializes at. It's basically a cache that is distributed. And that's the only thing it does. It keeps static content, and it serves it really fast, really well. And we saw before that our big bottleneck was not the time it takes to render the HTML or the JSON, but rather the time it takes to get our content there. So this looks like a promising thing to use to speed things up in the server-side rendered world. So how about if we use this, okay? We have our user, make requests, enters the URL. This makes a request to this new component, the CDN, which then doesn't find the home page in its cache. What happens then? It has to call the origin, which is our server, returns an HTML, all the files it needs, and it sends it back. So there's no real gain here, because we still have to call the server. And if anything, what we've added is an extra step in the middle, which is taking up more time, of course. So yeah, this is not better. But the next time a user accesses our page, their CDN will already have that page cached, which means that it will send it back directly. It doesn't need to call the server. So now we're talking about, instead of 300 milliseconds to get our site, we're talking about 30 milliseconds on average, which is much more promising. Except that this doesn't work. So my apologies, it doesn't work. This is broken, and the reason it's broken is because, if you remember, this is the code that we were using to serve our homepage, right? And notice the first line there in the handler, we're getting a cookie to identify a user. This could be a cookie, this could be an authorization header. This is some way of knowing what the session of the user is. So who's calling the server, right? And if we're doing this, if we are going through the process of caching the website, the first time a user calls this, it will get the card for that user, and then it will generate the page and send it back. So that means that the first user would get the right content because it would get identified right, but then we will send that page to every other user that calls. So we are caching the wrong stuff, and that basically blocks us because the way that we're rendering it is we have the home at the top, and the home depends on the header and the product list. The product list renders the products, and the header renders the cart. So if we want to render the home, all the childs have to be ready. This is how it works. And we can cache the home, we can cache the header, we can cache everything except the cart. And because of this tiny thing is blocking us from getting a 10 times performance boost in our server, a 10 times reduction in latency and the time the user takes to get the page. But, and this is where server-side rendering from back, the old school server-side rendering with PHP and all this, differs from how it is nowadays, because nowadays, what about if we could do, what about if we could do this and say, okay, this component is no longer a dependency. Okay, there's a bit of magic that's going on. And the thing is, this is a concept that I first learned about it from Astro.js, and then, but it goes back to 2019, 2020, which is the idea of creating component islands. So this is, the idea is that if you have your website, and your website is full of static content, HTML, but then you also have like dynamic content that you want to render for every user, you want to ideally cache your page, but you cannot because you're being blocked. This is the exact same problem that we have. So the idea is to instead create islands of interactivity where you will have your static content, then you'll have these islands, and it will not block the caching because the HTML is actually loaded, and then the islands, they are basically getting the data they need. They are hydrated once the page loads. That is the whole point. So what if we could do this in Go? Because this would solve our problem. Taking this approach would solve our problem of not being able to cache the home page. And the thing is, we can do, and it's great. We're going to be using HTMX. Okay, this is the header that we were using before. It's a bit too verbose, so let's simplify that to this, okay? So our header is the component that gets the cart count, and we are rendering that to a span, right? Very simple. But the problem, so what we want ideally is to be able to render this piece of code without getting the cart count as a parameter. So what we can do is use HTMX to do that. So the HTMX allows for lazy loading. HTMX, by the way, is a framework of JavaScript. It uses Axios to allow you to get modern browser features, access modern browser features using only HTML. And that's exactly what we're doing here. We're saying in our header, OK, I want you to get the cart endpoint, and I want you to trigger this on load. And in the meantime, we're going to be showing a loading text, or maybe like a GIF or something that indicates to the user that this data is being loaded. So now we can define our cart component. This is the one that's going to be loaded from using HTMX, and this is the one that will receive the cart count. So this ends up, as a handler, we will end up having something like this. Our homepage will get the list of products, because that is not really going to change that much, and we want to cache those. And then we basically pass those to the homepage, which now doesn't need the cart count, because we are going to be lazy loading it. And then we define another handler, which is going to be the one that it's going to be reading that cookie and rendering the card that ends up going into the HTML and ends up being hydrated eventually. So by going full stack, it allows you to it allows you to decide where on the spectrum you want to land. So this is what I call the full stack spectrum. You can go client-side rendered. This is JavaScript code that loads the HTML. This is the usual way. The usual way that we do it, and most places do it nowadays with SPAs. And then you have the ability to server-side render. So you can decide where on this spectrum you want to land. You can decide which components are going to be loaded and rendered on the database, on the server side, and which others are going to be eventually hydrated. And you get control. That's the key here. You get control over where on this spectrum you want to land, whereas in an SPA, you're locked to a binary choice where, OK, it's only client-side rendered. There's no way around it. And also, this is something that is only available when you do full stack. And this is something that I think the people in the JavaScript community, they figured out around 5, maybe 7 years ago. And you have like modern frameworks like Next, all these modern frameworks that put a focus on server-side rendering, especially also for CEO. I'm not an expert in CEO, so I'm not going to touch a lot about this. There is a very good article that the guys at Basel put out, I think, end of July. And it talked about discovery, how the Google bot, which is the one that indexes the websites that end up going into Google, discovers the pages. And the conclusion of it, they build several instances of sites, and the whole idea was to see which, if an SPA versus static site generated websites versus server-side rendered, and see which one was better. And the conclusion they had, it's a very, very hard to read table, but the conclusion they had is that out of all those, static site generation, that is HTML in an S3 bucket or some repository, doesn't change, ends up being the best one for CEO. Then you have things like incremental static regeneration, server-side rendering, client-side rendering, and server-side rendering and incremental static regeneration, which is the ones that we talked about, they end up being a lot better for page discovery for Googlebot. And that is something really important if you are in the modern web. You want to be discovered. And that is, you need to go full stack for that. So the code I've just shown is not really usable because, well, it doesn't have any tests, right? So it shouldn't be production ready. The good news is that you can write tests for your UI that's supported by Templ. And if you're interested in going production ready, I encourage you to go to the talk by Daniela after lunch. She's going to go through a project making a production ready Hello World. So I encourage you to go there. And thank you so much. And if you have any questions, I'll be more than happy to answer them.
Okay, questions?
Thank you very much for the talk. I started coding in Templ and noticed a massive memory usage drop. I'm glad I'm in a room with Go devs because Next.js RAM usage is just very, well, comical. I'm wondering when you would introduce something like Alpine or something like Vue to supplement more like interactive elements.
Mm-hmm. I haven't touched that much about Alpine personally. I use very basic HTMX, but I mean, it's a great framework. Like if you want to add that level of interactivity, which is ideal. Like when I think about JavaScript, it's like, okay, you have a nice drag and drop and you move things around. That you cannot do with with HTMX that easily. And then that's when you need to go into Alpine, and I think I've also tried Surreal, that's one I tried. And those, you can get that. And also the thing I like the most is, of course, the fact that you get the code right next to the component, the principle of locality, which is, I think, is one of the big advantages of using HTMX. Is a great design principle, but yeah.
Next question.
Oh yeah. When one of the things that's great about the JavaScript frameworks is hot reload. And
what, sorry?
Hot reload. You know, when you work in and you can see everything instantly in the browser. How good is Templ and working that way with HTMX if you want to see results instantly?
For hot reload, the thing is, you get some things, some features that I haven't touched a lot. In this talk especially, like you can do server-side events and all that stuff that allows you to be a more dynamic experience. The one I've touched is very basic in this case.
Do you have to keep reloading the page like when you make your changes to?
Sorry, what was that?
Do you have to keep reloading the page to see your changes.
Oh,
in the
okay.
browser?
Well, the thing is, you can the same way when I build. Well, let me go back a lot. I had to go back a lot. So the way I did it is that when you, so that's the big criticism for server-side rendering, right? The fact that when you make a submission of a form, so in this case you click the button, you get that HTML post back, right? And then you get the site flickering because it has to go into a new page. And you also, when you click back, you get that, oh, confirm, sending the form again, which I really hate. But in this case, you can overcome that side, that flickering, by, in this case, the card. You would not submit the, you would have the button, make the request using HTMX, and then the card would do, you would say, when you declare the tag, inside the very same form that's doing the request, you say, okay, with the HTML that you get back from the server, modify the card in the corner. And that way you have no flickering, and it's basically the same functionality that you would have in an SPA.
I think in regards to hot reload, because I've had a bit of a play with Templ, and I think it's the watch function in in Templ that allows.
Okay.
So the hot reload's okay. I've personally, being a
Right.
bit of a noob, found it to be a little bit janky. I think there are a couple of options that are available for hot reloading, which allow Go to be, kind of simulate that similar experience like JavaScript frameworks. The other one is Air.
Yes,
Anyone
that's
use
right.
Air?
That's right. Yeah.
So it's kind of similar to that. I found that it's a little bit tricky when you want to also compile a load of other files that aren't necessarily just Go, but it's not too dissimilar to front end.
Right.
If that helps.
Yeah, no, absolutely. Yeah, no, sorry, I didn't catch your question initially. That's the thing. Like when you have Templ is going to be watching your the Templ files, and then it's going to generate the Go files. But of course, if you're using regular HTTP server, it will not refresh your browser the same way that like Live Server and VS Code would do, or React would do. But you can Air works. I think for me, it works perfectly fine. For the reloading the Go files. Yeah.
Okay. Next question. Anyone else keen?
It's nice to see Templ being used a lot of places. My company uses it a lot as well, and I know that Aviva here somewhere also use it. Does JP Morgan have this in production anywhere?
I'm not aware. Like we personally, in our team, we do not have any of it in work, but I hope we do in the future.
Okay, thanks.
Next question. Cool. Okay. Thank you so much, Fernando.
Thank you so much.